All right, well, welcome. This is Perms and Goms Lesson 5 for Shaughnessy's class. Standard disclaimer, please make sure you're attending class. Otherwise, we can get started. This lesson is on combinations. Now, with a combination, the first couple lessons were permutations or fundamental counting principle. Combinations are a little bit different in the sense that in permutations or fundamental counting principle, every time we rearranged it, it counted as something different. The order mattered. Okay, if it was what was first was different than if we moved it and put it partway through the list. That doesn't happen with a combination. With a combination, the order doesn't matter. It's not a code. It's not an arrangement. It's kind of like the analogy I use is like stew. Okay, if you're making a stew, yeah, you can do it and you can put it in particular orders, and often we have particular orders. We cook things in order. But in all honesty, if you want to make a stew, you can just put it all in a pot and boil it. Doesn't really matter what order it is in. When all is said and done, you will have a stew. You'll have cooked meat, you'll have cooked veggies, you'll have some sort of broth with it. That's just the way it is. It's all the same thing after all is said and done. And that's combinations. Sometimes we don't care what the order is. For an example, committees. Committees is actually the big one. You're going to see on a lot of particular exams and that sort of thing. Often, if you see a committee, it's almost always a combination. It doesn't matter who else was put on the committee or the order they were put in. The committee, you say, okay, you three people go figure this out. And so it's just done. The committee is finished for them. Another one just to talk about, and I'm not trying to advocate gambling or anything, is the 649. We have the 649 here in Alberta. You basically have to pick 6 numbers between 1 and 49, and if you get those 6 numbers, you win the lottery, and it's really, really, really difficult to do. Very few people ever win the lottery, obviously. You don't have to get them in the right order. If you've ever watched your parents purchase a lottery ticket, or if you're 18 you've purchased one yourself, you have this little spot where you put little pencil marks next to various numbers. It doesn't matter what order you put those pencil marks in, it's the same ticket, and so the order doesn't matter, and so that's what it boils down to. Now with combinations, what you've got is your formula for that one is NCR. Okay, yesterday we had NPR, the other day we had NPR. NCR, choose. You're choosing, or your combinations. Once again, N has to be greater than R. So you've got that sort of idea. Now there's 2 ways to write combinations that you're likely to see. One is written like this with the NCR. The other one is a big open bracket, an N and an R, and a closing bracket on the other side. It kind of looks like a fraction, just there's no fraction line. That is a combination. It's just another notation that's used. Either way, the formula for that is, it's very similar to the permutations formula. N factorial over N minus R factorial. R factorial. Now all you've got in addition here, and I'm just going to quickly talk about this for a second, is this additional you're dividing by an R factorial. I've circled it there very lightly. This is dividing out the orders of the objects that are chosen. Okay? They are very similar formulas. Once you, and you may not even be able to see that pencil on the screen, but once you've got a permutation, you can just divide out however many orders there are. I can explain that in more detail. If you have any questions, please come back and talk to me. But nonetheless, that's the situation there. Now, when you're doing combinations, you've got a whole variety of different things. Okay? That's the formula. Now you can just evaluate some of them. So if I want to evaluate various combinations, I can. Now evaluating combinations, I can get evaluate 5 choose 3. Okay. Now I could do that by hand. It's 5 factorial over 5 minus 3 factorial, 3 factorial. Okay. And so what you'll get is 5 factorial over 2 factorial, 3 factorial. And so I can work this out. 2 factorial is easily 2. So I get 5 factorial over 2 times 3 factorial. Now, if I take the 5 factorial, I can go 5 times 4 times 3 factorial, so I've gone and done that. And now the 3 factorials can cancel. This factorial is kind of gone now. And so what I end up with is 5 times 4 divided by 2, or 20 divided by 2, or 10. Okay, lots of other opportunities to do this. You don't have to do that. If I wanted you to do 7, choose 3, you just go into the calculator. Now, you probably already have figured this out. But inside the calculator, handy dandy TI-84, you turn it on, clean out what's in there. Okay, 7, and then push the math key, and it brings up, this is not showing up very well. It brings up, trying to get the lighting a little bit better for you, brings up this menu. You scroll over to the right to probability, and that third option down is combination, so you choose that. 7 NCR3, you type that in, it's 35. Okay, you could do that. The other way, there's another notation for writing it, so I could do something like 8, choose 2. I write it like that, all is said and good, so I just go and do that again in the calculator. 8 math combination 2, and 8 choose 2 is 28. I don't know if you even saw that, but 28. So there you go, you're done. And so you've got a variety of different ways to evaluate combinations. Now, there's another thing to keep in mind here. If I go and do, and I'm talking about evaluate, and I'm going to move that up, and I'm going to do 5 choose 3 and 5 choose 2. Also, I'm going to do, for example, 10 choose 4 and 10 choose 6. Okay? Now, I'm going to use that notation for a while. I'll probably switch back and forth without even noticing it, but nonetheless, there you go. There's the notations. If I go and do these validations, or these questions, 5 choose 3 is 10. 10 choose 4 is 210. Now, if you pause it for a second and quickly evaluate these, you're going to get that that's 10, and that one is 210. And you're going to say, hey, wonder there's something weird going on. Basically, this is something that shows up with combinations. What you get is that n choose r is the same as n choose n minus r. So you end up with those things. So you end up with that. Sorry about the delay there. I just paused because one of the kids came into the room. So I got to reset all the focus and everything. N choose r is equal to n choose n minus r. This basically boils down to this. If that's n and that's r, 5 choose 3 is the same as 5 choose 5 minus 3. That's what 2 is. 10 choose 4 is the same as 10 choose 10 minus 4. That's what goes on. So you see this sort of thing. A big question that occurs here is why? Okay, and that's the why. Now this is the something cool. Okay, so I apologize that I kind of wrote that a little bit quicker than I expected. N choose r is equal to n choose n minus r. Okay, and that's what you get. Why? Well, this is why. Okay, and it's written out for you. It's basically the idea that if you're choosing, and you don't care what the order is, if you're choosing certain elements, once you choose those elements, you've essentially chosen, or you have chosen, the ones you don't want. So if you have 15 things or 10 things and I choose 4, it doesn't matter what order, I've chosen the 4, and I can do that so many ways, but I've also chosen the 6 I don't want. In the 5 choose 3 and the 5 choose 2. I had 5 objects, I chose 3, but I've also chosen the 2 I don't want. And if I'm not worried about the order, it ends up being the same thing. I like to think of it as, you remember the rhyme, and most of us did it at some point. Eeny, meeny, miny, mo, catch a tiger by the toe, if he hollers, let him go, eeny, meeny, miny, mo. You can do that, and you can do it in 2 different ways. Okay, that little rhyme does 2 different things. You can either say the person that I get at the end is the person that that gets the prize or gets to go first, or however you do it, or you can say that means you're not doing it. And so you have those options. Eeny, meeny, miny, moe does the same thing. You do the little rhyme, and you're either picking that person or you're throwing that person out of the list. So you've got that sort of idea. Okay. Continuing on with a few variety of different things, I've got this one. Okay, an example. Ali, Benji, Carmen, Donna, Evan are nominated to serve on a 3-person committee. The number of possible committees that can be formed. Now, if you've ever formed or served on a committee, you know the order doesn't matter. You just kind of get a group together and then they figure out what they're going to do. There are 1, 2, 3, 4, 5 people. So there are 5 people to choose from, and I've got to choose 3 of them. So I do 5 choose 3. And running to my handy dandy calculator, I think I just did this one actually, is 10. Okay, so there are 10 different committees that can be formed. Okay, and so this is how combinations come in handy. It's just a way of saying, you know, how many ways can you do it if you don't care about the order? Okay, list of 7 women and 8 men are nominated to form on a to serve on a 5-person committee. Okay, the number of committees that are possible if there are no restrictions. Well, no restrictions, so there are 15 people, and I've got to choose 5 of them because it's a 5-person committee. So 15 choose 5. Okay, and that is 3003. So there are 3003 different possible committees. Then you get into more specifics. There must be exactly 2 men. So exactly 2 men. So on this 5-person committee there are 2 men. Well, there are 8 men to choose from, and I've got to choose 2 of them. And you could go and figure that out, but that's not everything that's going on. There are 2 men on this 5-person committee. So if there are exactly 2 men on a 5-person committee, there has to be 3 women along with this. You're not done. You're like, well, okay, 2 men on this committee, great, but I've also got 7 women to choose from, and I need 3 of those. So I've got to do the men and the women. Remember, we've talked about this before. And means multiply. So 8 choose 2 times 7 choose 3, and I go and figure those out. Now this takes a moment to type in, I'm afraid. Okay, and if I've done my math correctly, if I've typed it all in, 980. There are 980 of these 3003 committees. There are 980 of them that have 2 men on them. Now, continuing on with this, and I've deliberately just used the same 2 men, but now I've changed it from exactly to at least 2 men. So in this case, there's 2 men and 3 women, or, now as soon as you see at least, there's multiple cases. So 2 men and 3 women, or I could have 3 men and 2 women, or I could have 4 men and 1 woman, or the other option is I could have 5 men and 0 women. Okay, so in this case here I've got a whole bunch of different cases, a whole bunch of different things to consider. And so I've got this sort of thing going on. So now I got to do each one. Now the 2 men and 3 women is right here. Okay, if you've done it before, you can just take the number. So 980. Okay, so I'm just doing that. I could redo this. I'm just not bothering. Or for the 3 men, there are 8 choose 3. There are 8 men, and I got to choose 3 of them. And for the 2 women, there are 7 women, and I've got to choose 2 of them. So I've got that one. Or 4 men. Well, there are 8 men, and I'm choosing 4. And there are 7 women, and I'm choosing 1 of them. Or there are 8 men, and I'm choosing 5. And there are 7 women, and I'm choosing 0. Now, you may not even write that 7 choose 0 out. Okay, you may just leave it, because 7 choose 0. How many ways can I choose none of them? Well, 1. I just did it. It's 1. So that's just how it works out to be. But I'm going to get 980 plus, and I'm just going to do all these ones. 8 choose 3, 7 choose 2 is 1,176. Then I've got 8 choose 4, 7 choose 1 is 490. And then I've got 8 choose 5 times 7 choose 0. And that one is 56. And so I've got all of these particular situations, and I am going to add them all together. So instead, add all these up: 980 plus 1176 plus 490 plus 56, and grand total is there are 2,702 possible committees that have at least 2 men. Now also too, with committees, this is where sometimes you can end up with a few different things that happen. This one, all women or all men. So there's a 5-man, no woman committee, or there's a 5-woman, no man committee. Now the 0 men or the 0 women I don't need to consider, so I'm not going to. 5 men, that's the 8 choose 5, or the 5 women, that's the 7 choose 5. And so if I have all of one gender, I've got that. Now 8 choose 5 I already know is 56. 7 choose 5. 7 choose 5 is 21. So I work that out. That is going to be, if I've done my math right, 77. So there are 77 committees that have all women or all men. Okay? Because there's multiple different men or there's multiple different women. Okay? So there's a few different options there. But that's how I end up with that. Looking at a few options, there's just a couple other little tricks you can do with combinations. This is a trick. There must be 4 women and 3 men on this 5-person committee. Now, if there are 4 women and 3 men, there's 7 people. But on a 5-person committee, can't be done. There are 0. You can look at it that way. Or you could say, well, there are... no, you just stop and think about this. I was just about to do like the 7 choose 4, and that would work. That would give me a number, but it doesn't make any sense. 0. Because we only want 5 people. So sometimes you just have to stop and think about the context. Now the biggest thing to talk about later on in the next couple days, you guys are going to be practicing PERMS, COMS, fundamental counting principle, keeping in mind permutations. Okay? That is when the order matters. And you cannot repeat objects. Oops. Cannot repeat objects. Also too, if you've got like elements, you must divide out the like elements. That's that dividing by the factorial that we were doing the other day. Okay, fundamental counting principle, very similar to permutations. The only thing is here you are allowed to repeat elements. Okay, this is what we did before. We know this. We're comfortable with that. With combinations, which is what we just did, okay, in this case the order does not matter. So whether I've selected Joe first or second or third or last, it doesn't matter. It's still the same group. So that's the situation there. And what you've got to do is you've got to use the context to figure that out. What are they talking about? Okay, what's the question talking about? Is it talking about committees? Is it talking about arranging books? Is it talking about making a code? Is it talking about forming a stew and cooking it all together? Is it talking about blending milkshakes? Is it talking about all these different things? Some are permutations, some are combinations, and the only way to know is to think about the context and think about what you know about the facts. Alright, so best wishes. Hopefully this helps with your homework, and otherwise have a great day.